In this lecture, we're going to learn about callback functions. And callback functions are functions that we pass as parameter to other functions to be called later in the body of those functions. Let's give a simple example because I think that's really confusing. Here we have a pair of functions. We have a function to encrypt a piece of text, and we have a function to decrypt a piece of text. In the body of this function, we won't do anything complicated. We will just add an integer to a given character representation. So if we have A, for example, and we add a 3, we will get B and C and D. And if we encrypt A, we will get a D because we just added 3 to the character representation of the A character. Hopefully this makes sense. If we encrypt this, we will get B, C, and get a D character as an output. If we decrypt D, we will get A because we will be subtracting, basically going backwards in the alphabet. This is the design I am after in these two functions here. Hopefully it makes sense. Now, we can use these two functions, encrypt and decrypt, as callbacks. And what we mean is that we can pass them to other functions to be called and used in the body of those other functions when necessary. We can look at our modify function here to really understand this. This is a function we can use to modify a string of text, and we want the flexibility to control whether our modification is going to be encrypting or decrypting. We can achieve this by passing a second parameter, which is going to be a function pointer, and it is going to be a function pointer to a function that returns a character. This is really important, and the function is going to take a character by const reference, and this is what we have in our parameter list here. Our parameter is called modifier, and it is going to be a function pointer to a function that returns car and takes const car reference n. This is what we have here. Now, if we go in the body of this function, we can call our callback function to do things. For example, if at runtime we specified that we want to encrypt and passed a function pointer to this encrypt function, we're going to loop around through the string, encrypting each character and storing the result back in our string using the array index operator here, and this is going to work. Once the loop is done, we will have our modified string, and we're going to return it by reference to be used by whoever called this function here, and this is going to work. The main message here is that we have passed a function pointer as a parameter to a function, and we have the flexibility to use this function pointer as a callback. We are basically going to call back this function in the body of our function here to use the function to do whatever it is we want to do. And this is going to give us the flexibility to do whatever we want with our modify function. We can encrypt, we can decrypt, we can really call any function that satisfies this signature here, and everything is going to fall in place, and this is really cool. Another example is to set up a modify function which is going to be working on a box container of std strings. The idea is really the same. We just have the flexibility to be able to specify multiple strings at once and store them in a box container object. This is what we achieve with this setup here. The parameter is going to be passed by reference because we want to modify this guy. And our callback is going to be exactly the same thing we saw in the slide. So this is what we have here. It is a function pointer to a function that returns a character and takes a parameter n, and the type of the parameter is going to be const car reference. This is what we have here. Because we have multiple strings inside, let's visualize this. We may have multiple strings inside, so this may be one string, another string, another string, another string. We need to set up a neutral loop, which is going to loop around, finding each instance of a string we have in our box container object. And then at each instance of a string, we're going to loop around to target each character in the string and modify it using our modifier callback function here. That's what we are doing. Notice that our code here depends on the getItem function here returning a reference, because we are going through that reference to modify the character in a string object using our modifier callback function here. Take some moment to really drive this in. It is nothing complicated, but the syntax can be a little bit confusing, especially for beginners. We can even take this a little further and set up a function that gets the best thing in a box container of std strings. And the way we achieve this, we set up a callback function called comparator here, and it is going to be used to decide which string is better than another string. We can go in the body of this function and set up a string which is going to be our best thing. So we're going to get the first string in our box container of std strings, and we're going to mark that as our best string for the moment. We're going to loop around trying to find a better string than what we have in best. And if we find that, we're going to assign that to best. And by the time we are done with this loop here, we will have the best string stored in our best variable here, and we will return it to be used by whoever happened to call this function here. Notice that we reserve the flexibility to define what is best. What is best might be a larger string in size. For example, we can set up a callback function here to use it to target the largest string in size in our box container of std strings. Or we can say that our best string is the greater string lexicographically. So we're going to be looping around trying to find the strings that comes later in alphabetical order, and that's going to be our best string. We can really set up things like this, and everything is going to fall in place. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is Callback Functions. We are going to grab the code from our template project and use that as a starting point. And I am going to put in my box container files. You can grab these files from the resource section of the lecture. You don't really have to type these things. We have set up this box container class in previous chapters. So now that we have this in, we can open this up in Visual Studio Code by dragging and dropping here. This is going to give us our project. We will have a main CPP file. We can clean that up a little bit. And we can take a look at box container here. And what I want you to see is that the getItemMember function has been modified to return a reference to an element in our box container of things. This is important because we will be using this method to modify the item at a given index in our box container objects. Now that we have this in, we can try and really learn about function callbacks. For that, we can include box container because we have it available in here. And we're going to set up our two callback functions, which are going to be encrypting and decrypting character data. So for example, if we have A, we can encrypt that to be a D. If we have a D, we can decrypt that to be an A. We can try these things out. So let's go down and say stdc out, and we can encrypt A, the character A, and we're going to see what we get to really understand what is happening here before we do more complicated things. So we can say stdendl here, and if we build and run this program, we're going to see that we will get that if we encrypt A using our encrypt function, we will get a D printed out. So the build should be good. We can bring up a terminal window, and we're going to clear and run Rooster. We're going to see that A encrypted becomes D, and if we try to decrypt D, we will get an A because we will be moving 3 places in our alphabet, if I can say it like that. So stdc out, D decrypted becomes, and we're going to decrypt the character D, which is uppercase. We can do something like this. And if we build and run this program, we can pass this through our GCC compiler. The build is going to be good, so we can clear and run Rooster. We're going to see that if we decrypt D, we will get an A. We can really do all kinds of crazy things with this. But what we really want to do is to use these functions as callbacks. And to do that, we will set up a function which is going to take them as parameters. The function is going to take a string by reference because we want to modify this std string, and we want the flexibility to either encrypt or decrypt in this modify function. And what we can do is call this and specify the string and pass a function pointer, which is either going to be encrypt or decrypt. And in the body of the function here, we will loop around calling our callback function here. Again, this is a callback function because we really intend to call it back in the body of this function here that takes a function pointer parameter n. So we're going to be looping around calling our callback to either encrypt or decrypt, and we're going to store the result back in our input string here, if I can say it like that. So with this setup we can go down and set up a string, for example, and we can initialize this with hello. We can do really anything we want. And we can go down and grab the result of our modification. For example, we can say std string, and we're going to say outcome. This is going to be our change, and we're going to initialize this with modify, and we're going to be modifying our input string, which is going to be message. And the second parameter is going to be the kind of modification we want to do. We may want to encrypt or decrypt this string here. So if we want to encrypt it, we might pass a function pointer to our encrypt function, and we do this by passing the name of the function directly. You see, that's the name of our function here, and we pass it directly in the place of this function pointer parameter. You really need to drive this home. And if we do this, we are going to modify our message by encrypting it, and the result is going to be stored back in our outcome string here. So if we go down, for example, and say std out and say outcome, and if we build and run this program, I hope you have an idea about what is going to happen. The build is going to be good, that's the first thing, but if we run it, we will see that we have encrypted our text. It is no longer hello, and the text is going to become this thing here, cool, because we are encrypting by adding 3 characters in our alphabet. For example, if we had H, let's try and type this out. We're going to say H, and if we try to add 3 slots or places to H, we will go 1, 2, 3, and we will hit K, which is what we have here, and we can keep doing the same thing. We will see that we will get this text if we encrypt our text here using the encrypt function. We can even decrypt, so we can say we want to decrypt. And if we do something like this, we will be going backwards. So let's try to build and see what is really happening here. The build is going to be good, and if we clear and run rooster, we will see that this is the text we're going to get. And if we go backwards in the alphabet by 3 characters on each character here, for H we will get E, for E we will get B, for L we will get I, and you can really see these things. Let's try and really understand this. We can try to draw this out again. And if we go backwards from H, we will hit E, 3 characters from the H here, and that's going to give us the E. And if you keep doing this thing, you will see that you will get this text here. But the message here is that we are able to control whether we want to encrypt or decrypt. But because we are passing a reference to the message string here, we don't even need to grab the return type. We can directly say modify here and print our string here, message. And we're going to see that this is going to give us exactly the same thing we had. If we encrypt, we will build and pass this through our GCC compiler. The build is going to be good, as you see here. And if we clear and run rooster, we will get our encrypted string. And this is what we have here. Hopefully you can see the usefulness of callback functions. They give you the flexibility to define what you want to do in your modifying functions or member functions, and this is really cool. We can even set up a box container version of this, which is going to have multiple strings stored in. So we can go down here and set that function up. The function is going to be really simple. It's going to take a box container of std strings n by reference. This is going to be our sentence, and we will have a callback function, which is going to be used to modify each character in each string. So because of that, each character in each string, hopefully you can understand that this is going to be a 2-dimensional loop that we will do in the body of our modified version here. So we're going to set up an outro loop, which is going to be looping around, targeting a single string in the box container of strings. And once we have the string, we will loop through the string targeting each character and encrypting it using our callback function here. And this is going to do what we want. One thing you should notice is that this code relies on the getItemMember function to return a reference, because we are going through that reference here to modify the underlying character in each string in our box container of std strings objects. Once we have the box container modified, we will return a reference to it to be used by whoever called this function. But we don't need to do that. We can just grab the box container object and use it to do things. Now, we can go down and set up a separator to play with us. So let's do stdc out and do a simple separator. And we can go down and set up our box container of std strings. It is nothing complicated. We set up a box container of std string objects here. It's going to be called quote, and we can add data. So we're going to say this guy is blue, my friend. That's going to be our input text. We can go in and print out the box container as is. We can modify it using encryption, and we can modify it back to decrypt it and get the original string data we had in, and we're going to see that this is going to work. Let's pass this through our GCC compiler. The build is going to be good, so we can clear and run rooster. And if we do this, we're going to see that we will be moving data. We will be using move semantics. What is going on here? We can clear and run rooster again to be able to see everything. This is the first thing we had before. So we will be adding stuff to our box container, and you will see that we will be using move semantics because we are adding literals. So a literal is really a temporary. So we will be stealing string data from those literals, and this is really cool. This is going to speed up things a little bit in our C++ program. Once we have the data in, we will print our initial data, and you're going to see that the data is going to be, the sky is blue, my friend. This is what we have. If we encrypt using our modify function, which takes a box container and a callback function, which is going to encrypt each character in each string in our box container, we're going to get this gibberish here. This is our encrypted string data, but we can decrypt it back and get our original data, and we will get the sky is blue, my friend, back. And this is really cool. You can really see that now we have the flexibility to do all kinds of crazy things using callback functions. To really play with this, I am going to give you another example, and this is going to be a function that tries to get the best string in our box container of std strings. What it is going to do, it is going to use a second callback function, which is going to be comparing strings. You can see that our comparator callback is going to return bool because it's going to be comparing things, and it is going to take two parameters that it is going to compare, and it is going to return whether the first one is better than the second one. And we will define which one is better using a bunch of callback functions. So in one scenario, we might decide that strings that are larger in size are better than those that are not larger in size, and we can define that using this callback function here. So we're going to go in and compare str1 to str2. And if str1 is greater than str2 in terms of size, we're going to return true. Otherwise, we're going to return false. We might even decide that the best string is the greater one in lexicographical order. So for example, if we have hello and world, world is going to be better than hello because world comes later in the alphabet. We might decide to do things that way. Now that we have our function here in place, we can use it in our main function here. Let's go down and set up a separator to really see these things in our terminal. And we can do something like this and get the best string in our code. And in the first scenario here, the best string is going to be the larger one in size. And in our second line here on line 89, we will see that we will be targeting the string which is greater lexicographically. We can do things like this. And you can see that what we are passing here are callback functions to fine tune on how we want our best string decided in this code box container of std strings. Hopefully this is making sense. We can build our code and see what we get. We can pass this through our GCC compiler. The build is going to be good, so we can clear and run rooster, and we will see that the friend string here is larger in size. If we go in, we will see that it has 5 characters, I guess 6 characters in, so it is larger than any other string we have in our box container. But if we decide that the best string is 1, which is greater lexicographically, our best thing is going to be sky, because this is the last thing in the alphabet. If you go down, you will see that it is the case here, and this is really cool. This is really all I had to share in this lecture, showing you how you can set up all kinds of crazy callbacks in your C++ program. A callback is basically a function that you intend to be called in another function, and you set up that mechanism by passing the callback function as a parameter to the function in which you want it to be called later. And the callback function is passed as a parameter through the function pointer mechanism. The function pointer has to match the type of the function we intend to call. For example, here the return type is char, the input is const char reference. This has to match with any kind of callback that we pass, because if they don't, you will get a compiler error. The compiler won't know that it can match this callback to the actual function that you pass at runtime. We are going to stop here in this lecture. In the next one, we will see that we can set up type aliases for function pointers, because some people think that the function pointer syntax here is really ugly. We're going to see ways we can simplify that in the next lecture. Go ahead and finish up here and meet me there.